Hello and welcome. This short video introduces an incredibly useful concept called present value analysis. We'll work on the intuition now and apply the idea in some practice problems in some other videos. You may also hear the terms time value of money, discounted cash flows, and net present value. All of these are closely related to present value analysis. The motivating question is, how do we value costs and benefits, such as cash outflows or cash inflows, that occur in the future or over the course of several years? The answer is using present value analysis. The idea is to convert value received in the future or a stream of value received over time into a value to be received today. This isn't just something you need for economics. The concept is inescapable. You will almost surely come across it many times in your life. When you borrow money, as many of us do, to make big purchases like a car or a house, whether you realize it or not, you're implicitly doing some present value calculations, and so is the individual who's lending you the money. When you save by investing in bonds or stocks, you're implicitly making an assessment about the present value of a future cash flow. The price you pay for a stock or bond is the present value of the cash flows you receive from that stock or bond in the future. And if you plan to do finance for a living, well, pretty much everything in finance hinges on present value analysis. I'll illustrate the intuition behind present value with a thought experiment. Here's something to think about. Would you rather receive $1,000 today or $1,000 10 years from today? If you're like me, you don't have to think very hard about this. I'll take the $1,000 today every time, because there's no benefit to waiting 10 years to receive the $1,000, and there's lots of things I could do with $1,000 today anyhow. What if I made the deal $900 today or $1,000 10 years from now? You might have to think about that one a little bit harder, but if you're like me, I'd still take the payment today. What about $500 today or $1,000 in the future? Well, in this case, I'll wait and I'll take the $1,000 10 years from now. So what have we discovered from this thought experiment? Well, we've discovered that equal payments that are separated in time are not worth the same amount. In fact, $1,000 10 years from today is worth something less than $1,000 today. And though we don't know exactly what it is, presumably since somewhere between $900 and $500 we changed our mind about when to take the payment, there's some number in here that would leave us just indifferent to taking $1,000 in the future or some payment today. And for the sake of argument, we'll say that number is $744. We'll come back to where that came from in just a second. Now, if you're thinking to yourself, this all has something to do with interest rates, you're exactly correct. The interest rate is the annual rate at which you are compensated for deferring consumption and perhaps taking on some risk. And to a borrower, the interest rate is the price of pulling consumption out of the future into the present. Now let's see how this all fits together by taking a look at where that $744 number I came up with came from. Suppose you had access to a bank that you knew was going to pay you 3% interest per year for 10 years, and you were certain of this. There was no risk involved. Well, if we took that $744 and deposited it in the bank and left it there along with accumulated interest, how much would we end up with? To figure that out, let's just show you an example of how you'd figure out how much you had in 1 year. We take $744, multiply it by 1 plus 3% or 0.03, and it turns out that this is equal to about $766. That's how much you'd have after 1 year. In 2 years, well, we'd take this 766 that we were going to let ride and multiply it by 1.03 again, and that turns out to be something like $789. I may be off a little bit, but that's about right. Well, you repeat this calculation a total of 10 times, and that would give you your balance in 10 years. Or you could take the shortcut here and take $744, the amount we start with, multiply it by 1.03 to the 10th power for 10 years, it turns out that's going to give you exactly $1,000. So what this means is, since I said I was indifferent between $744 today and $1,000 10 years from now, it means I was willing to accept a 3% interest rate for 10 years in order to defer consumption for 10 years. Let's talk about this in some more abstract terms. We're going to call the payment we were discussing receiving in the present value, or PV. And if we multiply that by 1 plus the interest rate raised to the power n, where n is the number of years between now and the future, that is going to be equal to, in this case it was the $1,000, or the future value. This is one general version of an equation that relates present value to future value. We can also rearrange this equation just a little bit to show present value in terms of future value and the interest rate. We essentially divide both sides by 1 plus the interest rate to the power n, so that we have present value equals future value divided by 1 plus the interest rate to the nth power. That's the present value of some cash flow received n years into the future, assuming we require an interest rate of I. So let's summarize really quick. What we've discovered is that $1 today is worth more than $1 in the future because we can earn interest on our money. And we earn interest because we require compensation for being patient. By the way, this little symbol right here means is preferred to. So $1 today is preferred to $1 in the future. Next, we learn that interest is compensation for being patient, and it's the price you have to pay for being impatient. It also has something to do with risk, and we'll talk about that later, but it's a good idea to think of things that might cause interest rates to be higher or lower. And finally, we learn that in order to compare the value of the payment received in the future to a value today, we take the present value. And we found that the present value is equal to the future value discounted by an amount that is determined by the interest rate and the number of years between the present and the future. Thanks for watching. I encourage you to take a look at some of the other videos where we'll work through some practice problems that require us to apply this concept.